Understanding the pipeline. Up to now, we've really just been using Windows PowerShell as a shell. I mean, sure, some of the commands might be different from other shells, like command.exe that you've used, but ultimately, it's really doing the same thing. You run a command, you get a list of processes. You run another command, you get a list of files and folders. It doesn't really seem revolutionary. Where does the power come in? Well, this is the nugget where you'll hopefully see where the power in Windows PowerShell comes from. Here's what we'll cover. We'll start by discussing why you need a pipeline at all. And we'll try and visualize the pipeline to understand what's going on when you run commands in Windows PowerShell. Then we'll look at some specific examples of services in the pipeline, processes in the pipeline, so that you can sort of see how real-world tasks line up with this whole pipeline concept. We'll look at how Windows PowerShell lets you pipe things to a file or a printer or many other places. And we'll look at two different ways of getting output into the PowerShell window, through write output and write host. Two commands that, well, seem very similar, but in fact have very unique capabilities and some very important differences. Let's start with why exactly we need a pipeline and how it all sort of fits in. To really kind of explain this, we need to take a look at how some other shells, such as the command.exe shell that you might be familiar with, but perhaps more importantly, how some Unix and Linux shells work. Now, although we're all Windows administrators here, it's important to understand that Unix and Linux administration has almost always been done primarily through the command line. So when Microsoft looked at how to improve administration in Windows, they really looked at some of the models for administration that were used by Unix and Linux. And that's where the shell came into play. One of the things they noticed about those shells is that you tend to run a command. Maybe it's a command that gets a list of running processes or a list of files or something else. And that command actually produces a text file. So here's my little icon for a text file. And maybe this is just a list of processes or it's a list of services. Let's say, for example, it's a list of processes. It's usually a comma format or a column formatted list. So maybe there'll be a column for the process ID and a column for the name. Maybe another column indicating whether or not the process is responding. Sometimes processes get locked up and they're not responding to the operating system. So then in each of these columns you would have values. So maybe a process ID of 5, a process name of Notepad, and then maybe it was true for responding. And the next process might have a 10 for the process ID. Maybe this is LSASS, and that's true because it's responding. So if you want to do something with that information, you have to start with the text file as the input to the next command. Usually in the Unix world, this would be a command called Grep. And what this is designed to do is say, I want you to look at a certain value in each column, and I want you to keep the entire line if that's true. So in column 1, 2, 3, 4, 5, I want you to look and see if the word Notepad is there. And if you find the word Notepad, then you keep that entire line. And then that actually goes out to yet another text file. So we take a command to get all the processes, we create a text file, that serves as input to another command which filters through some of it, which outputs yet another text file, and then maybe I'm going to take that text file, which at this point might only contain this information, and send that to yet another command, maybe kill. And that's going to allow it to kill this particular process. Well, this is kind of a complicated way to do things. It's very common in the Unix and Linux world because those operating systems are based on text. Almost everything in Unix, for example, can be represented as a file folder or a text file. Most programs or applications keep their configuration information in text files. This is a perfect model for those operating systems. It's not really such a great model for Windows. But you can sort of see how this all forms a pipeline. Commands produce text, which gets sent on to the next command, which gets sent on to the next command, and so forth. If you don't want to call it a pipeline, maybe call it a sequence. So to sort of draw this out as a sequence, let's say we have this sequence of things, and there's a chronology, there's a time, and things are going to be performed in a certain order. we're going to perform the first thing, and then it's going to pass some sort of output to the second thing we want to do, which is going to pass some sort of output on to the third thing we want to do, which will pass something on to the fourth thing we want to do, which will pass it on, and maybe that's the last thing we wanted to do, and we just want to see the actual results of that. So this is really how it's built in a Unix environment to run a command, take its output, send it to the next command. So when the Windows PowerShell team decided to sit down and try and build something for Windows, they decided to duplicate that same sort of sequential process where commands can pass things on to the next command to pass things on to the next command. And they decided that this sequence of events would be called a pipeline. For example, maybe A is getting a bunch of processes, and B is filtering those so that we're only keeping the ones that we want. And then C is maybe stopping the processes that are left, and then D is perhaps formatting the results, maybe in a table or in a list, so that we can see them in whatever way we want to see them. So the idea is to take several different things, stack them all together, and let them share information and pass information to one another in this sequence of events that's ultimately called a pipeline. So let's sort of visualize what that would look like in Windows PowerShell. Now the first thing to remember is what we said in the previous nugget, that everything in Windows PowerShell is an object. So if we run a commandlet like get service, it's going to retrieve not a list of services, but a bunch of service objects. And it puts those service objects into the pipeline. So those service objects live in the pipeline. Now, perhaps there's another command in the pipeline. The next command in the pipeline might be a filtering commandlet. We'll look at this later, but for now, just know that there's a commandlet called whereObject, and its job is to evaluate objects and either leave them in the pipeline if they meet your criteria, or take them out of the pipeline. Maybe we only want to look for services that are running, and we want to filter out the services which are not running. So getService produces these service objects and passes them on to whereObject. WhereObject filters out the ones that don't meet our criteria, and then those objects might be passed on to yet another command, such as formatList, so that the objects go from getService to whereObject, and then whatever's left gets passed to formatList. Let's try and look at that in the shell. I'm going to get just a little bit ahead of myself by using that whereObject commandlet that I haven't introduced yet, but we will be covering that in just a couple of nuggets. So let's get some room on the screen to work here. GetService, which if I hit enter just produces a bunch of service objects. So it put those objects in the pipeline, but I didn't tell it to do anything else with them, so I wound up getting this text list. So let's say GetService whereObject, and we need to specify some criteria. I know that these services have a status property which is either running or stopped. So let's just keep the ones where the status property equals running. Notice I got a much shorter list that time. So whereObject took all the objects that came out of getService, evaluated each one of them, kept the ones that met my criteria, and put them in the pipeline. Now, I hadn't told it to do anything else, and so PowerShell has a default action of displaying those objects in some sort of text. But what if that's not the format I wanted? What if I don't want columns? Well, we already looked at a command called formatList, so I'll take whatever objects come out of whereObject and pipe them to formatList. Now I get those same objects formatted differently. Again though, once the objects were left in the pipeline, they came out as text. So let's take a look at how that actually works in Windows PowerShell. When you've got this fancy little pipeline, and you put a command into it like getService, you don't know it, but at the end of the pipeline there's a special commandlet called outDefault. You don't ever have to specify it. It's actually hard-coded in Windows PowerShell. OutDefault's job is to take objects and turn them into a text list. So when getService puts a bunch of service objects into the pipeline, if I don't specify any other command, those objects wind up at OutDefault. OutDefault takes those objects, takes some of their properties, such as status and name, and produces the different lines of output that we see. If I have a different pipeline, and I've put the command getService, and then I've put the command whereObject, which is filtering some of those objects out of the pipeline. Remember, at the end of the pipeline, there's always this OutDefault. So I start off with a bunch of service objects. Those get piped to whereObject. WhereObject run and filters out the ones that don't meet my criteria. Now, if I haven't specified any other command, those objects wind up being picked up by OutDefault. OutDefault takes whatever objects are left in the pipeline at that point and uses some of their properties to construct the text output that we see on the screen. So let's open the shell back up and see that again. I'm going to do the same thing, but I want you to kind of think about what's really going on under the hood. I'm going to run getService, pipe to whereObject, and I'm going to give it my criteria. Only keep the ones where the status property equals running. I'm not specifying OutDefault, but it's always there at the end of the pipeline. So getService is going to retrieve all the service objects. It pipes those to whereObject. WhereObject is going to keep the ones that have a status property equal to running. Anything that does not have a status property equal to running is taken out of the pipeline. Anything that's left in the pipeline will get passed to OutDefault. And if you want, you can actually specify OutDefault yourself, and you get the same results. OutDefault is always at the end of the pipeline. It's okay if you put it in there, it'll have the same effect. But if you don't specify it, you still get the same text list. OutDefault is just taking some of the properties of the objects and creating this text display. Now remember, we can always take something like getService, pipe it to getMember, and we can see what properties and methods this object has. We can see that the status, display name, and name properties are the three that Windows PowerShell picks up to display by default. There are lots of other properties in here. They're just not used as part of the default display. So that's how the pipeline works to pass objects from one command to another, and it's how objects at the end of the pipeline get turned into a text display that we can see and understand. So let's start with a fresh Windows PowerShell and take a look at some of the things we can do with services in the pipeline. For example, just to sort of give ourselves a starting point, we know that getService will retrieve all the services that are running on the computer. What other things can PowerShell do with services? You can stop them, start them, suspend them, set them. Let's take a look at set service. Notice one of the things we can set here is a startup type of automatic, manual, or disabled. So we could, for example, say getService, pipe all of those to whereObject, keep the ones that have a status property of stopped, pipe those to setService, and give them a startup type of disabled. If we're not currently running them, then let's disable them so that they won't run at all. Because setService modifies the system, we can add that what-if parameter to see what it actually would have done. We can see that it would have performed the set service on a number of different services, none of which are currently running on the computer. Here's another example. getService. This time, let's only keep the ones where the status property is equal to stopped, and pipe them to startService. So we're going to try and start all the services that are currently stopped. Again, let's add what if just so we can see what would happen without actually modifying what's going on the computer. It would have performed the start service on all these different services which are not currently started. So you get a lot of flexibility to combine these commands in different ways to perform a number of different administrative tasks which might otherwise require you to poke around in a GUI. Maybe you would miss one service that was stopped. Well, PowerShell won't miss anything. And at the end of the pipeline, you always get that text output so that you can see what happened or see what objects were left in the pipeline. We can do something similar with process objects. For example, we know that getProcess or its alias, PS, will return a list of processes. We might want to say, get all the processes, stop all the processes. That would probably be a little bit dangerous thing to do. At some point that'll probably blue screen the computer, but remember we can always add that what if. This is going to get all the process objects, pipe them to the commandlet which will stop each one of them in turn. If we hit enter, we can see that it would have in fact tried to stop every single process on the computer, in alphabetical order no less, since that's the order in which they came out of getProcess. So just being able to stack these different commands together, to get a bunch of objects, to maybe filter some of them out, and then do something useful with those objects, this is at the very basis of what Windows PowerShell is all about. Let me give you one more example. Now this time, rather than actually typing commands, I want to kind of sketch this out so we can really visualize it. Let's say you're using Windows PowerShell to manage an Exchange Server 2007 computer. One of the commands you can run is get Mailbox. As you might expect, this is going to get all of the mailboxes associated with that server. And you can specify different parameters to indicate what server you want. Maybe you want to get all the mailboxes in your entire organization. So we're just going to start with get Mailbox as sort of a conceptual command. The next thing we'll put in the pipeline is that filtering commandlet, where object. And maybe the criteria we're going to specify is to only keep those mailboxes where the size property is greater than 10 megabytes. Now that's not actually the way we would type the criteria. Again, I'm just sort of sketching this out so we can visualize what this is doing. So at this point in the pipeline, here, we have all of the mailboxes. At this point in the pipeline, here, after where object is run, we only have those mailboxes which are larger than 10 megabytes. So we're going to pipe those mailboxes to another command called move mailbox and specify a different mailbox storage server. So maybe the practical upshot of this is to take all of our largest mailboxes and move them to a different mailbox server. Maybe our criteria would be different. Maybe we would only want those mailboxes belonging to people in a particular department, or only those mailboxes which were under a certain size. We want to grab the smaller mailboxes, because maybe the server we want to move them to is an older server that we're trying to get more use out of. The point is that by connecting these three commands together in the pipeline, we can get a set of results, fine-tune that to meet our criteria, and then take action with what's left. The pipeline in Windows PowerShell is really what enables that sort of functionality. So we've said that this out default commandlet sits at the end of the pipeline, takes whatever objects are at the end of the pipeline, and creates a text list that appears on the screen. Let's see what other commands exist that use the out verb. Well, there's out default, but we've also got out file, out host, out null, out printer, and out string. All of these are designed to take objects and get them into a different place. If out default gets them into the console window, let's see what out file does. Get service, pipe to, out file, and we'll give it a file name, services.txt. Now let's type that. Type C services.txt. This is something we looked at before, but now you understand that all of the out commandlets are really there to take objects, convert them to some sort of text list, and then put that text list in a different place. either the console window or in this case a file. And there's this other one called out printer. Let's ask for help with out printer. Sends output to a printer. Certainly useful. Maybe you want to get a list of processes and put those out to a printer. And we need to give it the name of the printer. Maybe we've got an HP LaserJet 4. So all of these different out commandlets give you different ways of getting objects into a text list and then getting that text list into a different place. So you get a lot of flexibility for determining where you want the output to go, either on the host window here, in a file, perhaps in a printer. Next, I want to talk about one of the ways in which you can get objects into the pipeline yourself. It's a command called write output, which has an alias that's just called write, although to avoid some confusion, I'm going to try and use write output, the full commandlet name, rather than using the alias. So if I type write output and then just give it a string like hello, hello appears at the console window. There's another command out there that can also produce output at the console window. It's called write host. And they seem to do identical things. If we read the help on these, though, help write output tells us that this writes objects to the success pipeline. Help with write host tells us that this displays object by using the host user interface. And you can see that there's actually the ability to set a different foreground color and a different background color. So I can say write host hello in a foreground color of yellow, and that's what will appear. How is that different from write output hello with a foreground color of yellow? Oh, it doesn't seem to actually work the same way. It wrote out hello, but then it wrote everything else I gave it as a literal string. It didn't take these as another parameter. Let's go back to that help for write output. We see that write output does not have a foreground parameter. So it would seem like write host gives you the most flexibility, right? Well, let's look at the two different ways that these guys work. Remember that we have a pipeline in Windows PowerShell, and all commands run in a pipeline. And at the end of the pipeline is out default. So write output actually puts objects into the pipeline. Write host, on the other hand, does not put objects into the pipeline. Now we've already said that the purpose of out default is to take whatever objects are in the pipeline, turn them into some sort of text list, and then put that text list into the console window. Write host writes directly to the console window. That's why it's able to specify foreground and background colors. Write output puts objects into the pipeline. Of course, those objects, once they're in the pipeline, wind up at out default, and out default will get them into the console window. So in a simple example like this, it does seem as if these two commands work the same way. Let's take a little bit more complicated example, though, using the pipeline. I'm going to use write output to put some objects into the pipeline. At the end of the pipeline is out default. And remember, out default will take whatever's left at the end of the pipeline and put it into the console window. However, in the middle of the pipeline this time, I'm going to use that where object again. So it's possible for write output to put an object into the pipeline, have where object get that object, and then filter it out. That means there are no objects after where object. If there are no objects in the pipeline, there's nothing for out default to pick up and display in the console window. Let's take a look at that in the shell. Write output hello. Okay, it did that. We know that hello is a string, because if we take hello and we pipe it to getMember, getMember tells us that this is an object of the string type. And one of the properties it has is length. So if we say write output hello, pipe that object to where object, and only keep those objects that have a length property greater than 100. Our little 5-character string does not have a length greater than 100, so where object filters it out. When I hit enter, the result is nothing, because after where object, there were no more objects in the pipeline. There was nothing for out default to display, and so it displayed nothing. Write host works very differently in this circumstance. Write host wrote hello directly to the console window. There were no objects placed into the pipeline. Therefore, there were no objects given to where object. So it had no input, so it created no output. It didn't have an opportunity to filter this out of the pipeline because write host never put that into the pipeline. It just put it directly at the console window. So those are the two different ways you have of creating output. One of them puts objects into the pipeline, where subsequent commands have an opportunity to modify them. Write host puts things directly to the console window. If there's anything later in the pipeline, it doesn't matter, because write host didn't put anything into the console window to begin with. In this nugget, we looked at why the pipeline makes Windows PowerShell such a powerful administrative tool. We talked about why the pipeline exists, and we looked at some examples of how the pipeline works visually. Then we looked at some real-world examples of services and processes being used in the pipeline. We looked at how to pipe objects to a file or to a printer, and we looked at two different ways of getting output into the console window. Write output, which writes to the pipeline, and write host, which actually writes things directly to the console and bypasses the pipeline. I hope this has been informative for you, and I'd like to thank you for viewing.